everyone, welcome back to my YouTube channel. I am Nihar, studying in Sri Venkateswara College of Engineering, Bangalore, in the Department of Computer Science and Cybersecurity. Today I am going to speak about the subject operating systems about semaphores. Introduction to semaphores. Semaphores are synchronization tool used in operating system to control access to shared resources. They allow multiple processes or threads to safely access shared resources without interference. Semaphores can be binary, mutex, or counting with different implementations for each. Types of semaphores. There are two types of semaphores, counting semaphore as well as the binary semaphore. So coming to the first, binary semaphores. Binary semaphores have two states, 0 and 1. 0 is the locked state and 1 is the unlocked state. They are commonly used to control access to critical sections in a code. Binary semaphores are typically implemented using atomic operations to ensure thread safety. Counting semaphores. Counting semaphores can have an initial value which is to be greater than 1. They allow multiple threads to access a shared resource up to a certain limit. Counting semaphores are useful for scenarios where multiple resources are available. Semaphore operations. Semaphore operations include wait, which is denoted by the letter P, and signal, which is denoted by the letter V operations. So therefore it is also called as P and V operations. The wait operation decrements the semaphore value and blocks if it reaches 0. The signal operations increments the semaphore value and unblocks waiting threads if necessary. Mutex versus semaphore. Mutexes are binary semaphores used for mutual exclusion between threads. Semaphores can be used for both mutual exclusion and synchronization between the threads. Mutexes are simpler and faster than semaphores but are limited in functionality. Deadlock and starvation. Deadlock can occur when multiple threads are waiting for resources that are held by each other. Starvation happens when a thread is perpetually blocked from accessing a resource. Proper semaphore usage and careful design can prevent deadlock and starvation. Concurrent programs. Now let's see the semaphore implementation. Semaphores can be implemented using various synchronizations primitive like atomic operations or mutexes. Operating system provide built-in semaphore support for efficient synchronization. Semaphore implements may vary in terms of performance and also it may vary in terms of features. Semaphore applications. Semaphores are widely used in operating system for resource sharing and synchronization. They are essential for managing concurrent access to shared data structures. Semaphore-based solutions are prevalent in multi-threaded and parallel programming environments. The semaphore best practices. Always release a semaphore after acquiring it to avoid resource leaks. Use appropriate semaphore types, that is the binary semaphore or the counting semaphore based on the synchronization needs. Avoid unnecessary blocking operations to prevent performance degradation. Now let's see what are the limitations of semaphore. Semaphore do not prevent race conditions or guarantee data consistency on their own. Improper semaphore usage can lead to deadlocks, live locks, starvation, and other synchronization issues. Careful design and testing are crucial for effective semaphore-based synchronization. Now let's see the small key difference between the semaphore and also the spin lock. Semaphore block a thread when a resource is unavailable, while the spin lock continuously poll until the resource is available. Spin locks are more suitable for situations where waiting is short and resource continuation is low. Semaphores are preferred for scenarios with longer waits and higher resource continuation. Now let's see where we can use the semaphore. Semaphores are commonly used in producer and consumer problems or programs to coordinate the data exchange between the two threads. In multi-threaded server applications, semaphores are employed to limit the number of concurrent connections. The real-time system utilizes semaphore for task synchronization and also the task prioritization. Semaphore in modern computing. With the rise of multi-core processors and parallel computing, semaphores play a crucial role in ensuring thread safety and synchronization. Advanced synchronization techniques like reader-writer locks and transactional memory are also used alongside semaphores. Semaphores remain a fundamental building block for concurrent programming in modern computing environments. Semaphores are powerful synchronization tool for managing shared resources in concurrent programs. Understanding semaphore concepts are best practices is essential for developing robust and efficient multi-threaded applications. So this was all about the semaphores, the types of semaphores, and also where we can implement semaphores, how we can implement semaphores. Thank you for your attention. ವಿಡಿಯೋ ನಿಮಗೆ ಇಷ್ಟ ಆಗಿದ್ರೆ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ ಹಾಗೂ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಥ್ಯಾಂಕ್ ಯು.